Goodbye, spooky and hello, chilly November. November, whose name, by the way, is derived from the Latin novum for 9, and of course is the 11th month of our modern Gregorian calendar, thus demonstrating that naming is hard and versioning is important, two problems we still struggle with centuries later. Which means this week we talk with Peter Klimek from Imperva about strategies for securing APIs and how newer design patterns hold more promise for security, but still have plenty of problems to solve. In the news segment, a webhook turns into RCE, a checklist for minimum security, an assessment of end-to-end encryption, privacy engineering specialties, and more. Turn to 11 and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today. Is your mobile app really secure? New vulnerabilities pop up every day, and malicious actors look for easy targets on app marketplaces to exploit. Securing your app's valuable IP and data is critical. GuardSquare security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection prevent reverse engineering and automatically detect tampering, making your app a difficult target for attackers. Learn more at securityweekly.com/GuardSquare.
This is episode 172, recorded November 1st, 2021. I'm your host, Mike Shima, and while I was too sad to see October go by, I'm always happy to welcome Mr. John Kinsella. Hello, John.
And I'm happy to be here. And we've got a special treat for our guest this week because we're going to do a 2-hour episode focusing on what is CryptoCoin.
Take it away, John. Surprise. While we get everything ready for this special non-April 1st episode of November 1st CryptoCoin by John, let's go through some advertisements. InfoSec World 2021 is proud to announce its keynote lineup for this year's event. Hear from Robert Herjavec, plus heads of security at the NFL, TikTok, U.S. Department of Homeland Security, Stanford University, and more. Plus, Security Weekly listeners save 20% on digital pass registration. Visit securityweekly.com/ISW2021 to register now. Then you can join us for our next live webcast on November 4th, coming up soon, to learn about pragmatic steps to reduce your software supply chain risk. Then join us November 11th to learn the key insights and takeaways from the 2021 OWASP Top 10. Who knows, maybe it won't have cross-site scripting on it anymore. Visit securityweekly.com/webcasts to save your seat. And don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. While John is continuing to get his 2-hour presentation ready, I'll introduce our guest, who's Peter Klimek, the Director of Technology with the Office of the CTO at Imperva, a market leader in edge, application, and data security. Klimek helps global customers protect their applications, data, and websites from security threats through all stages of their digital journey. Prior to Imperva, he held roles at Kaspersky, TransUnion, and Zebra Technologies as a solutions architect, security analyst, and an engineer. Hello, Peter. Thank you for joining us.
It's a pleasure to be back on the show.
And we're happy to have you back, indeed. And last time we, in fact, chatted about some API security. And I don't think we finished because there's plenty more API security to talk about this time. But I think we're also going to perhaps go in a slightly different direction. Talking once again about the challenges from customers, what you see them running into. But when we chatted a little bit before this, there were some interesting things that you had noted about some of the design patterns that are changing, and the good and the bad, and since we have to stick to the rule of three, the ugly as well that might come through, to talk about kind of the difference between, as we're moving away, or maybe companies are starting to move away from maybe RESTful types of APIs and going into GraphQL-based APIs. So that's a little bit of a teaser, but as we start that off, what have you kind of seen as new challenges, or the challenges that companies are still struggling with in terms of API security?
Yeah, I think it's helpful to just first level set on just some of the reasons why we see APIs being everywhere. They've always been around, I think, in application development, really from the early 2000s. A lot of organizations were adopting web services. And something that we talked about quite a bit in the last podcast was talking about this shift in migration to more serverless and microservices and everything around those lines. And if you think about the way that those microservices communicate, they of course are going to use APIs as really that communication language. But above and beyond that, ultimately what we've seen is its proliferation of mobile applications, IoT devices. All of those are using APIs exposed externally. We have changes in web development technologies. So over the last few years, technologies like React and Angular, basically they make up what you call single page applications and architectures for those, as well as newer Jamstack architectures, which is just a combination of JavaScript APIs and Markdown. So the A in Jamstack is API. And then last but not least, of course, you have entire businesses that were built on just exposing APIs. Probably the most common and prolific I could really kind of name off there was like Twilio and SendGrid and some of the other services, which were just really going and exposing APIs externally. And so really the biggest thing is we just started seeing a lot more of them being developed and exposed externally for one of those four reasons, really.
Yeah, and I think, I'm going to guess that a lot of the basics are still important. Where are your APIs? How do you enumerate them? Where are all of your endpoints? Have some input validation, things like that. But it sounds like there's possibly, well, let me ask a more open-ended question. Is that it? Are there newer and different, more interesting types of problems that companies and organizations are still running into as they are shifting to a very pure type of API type of offering?
Yeah, definitely. This was actually, I think, one of the more interesting things just for me as, someone who's been in security for such a long time, was even seeing how long it took OWASP to come out with an API specific top 10. For years and years and years, basically everyone kind of took the position of, let's just saying, well, APIs are actually just like web applications. They just don't render and display HTML pages. So yeah, the OWASP top 10 is kind of good enough for this. And it really, I think, took that proliferation, that explosion of APIs, as well as really kind of the time of seeing how attackers were starting to go and actually target specific APIs, where they kind of took a step back and said, okay, well, wait a minute, maybe we need to go and actually come up with a new API specific top 10. But at the same time, when you went and actually looked in it, sure, there's lots of new names. There's like broken object level authorization, broken function level authorization, all sorts of different types of vulnerabilities. When you kind of map them out to the original one, what you saw was about 70% of them were effectively a rehash of what we've pretty much previously have done. But then the other 30% were approximately new. And really some interesting ones to kind of dig into there, as well as we started to see the strategies that teams are using to actually try to protect against those.
Yeah, and some of those, we've talked on the show quite a bit just about the authentication part of APIs, because that's where organizations are trying to figure out, here's a token. Are we handling the token correctly? Are we protecting the secrets for that token correctly? And we start to get into that alphabet soup of whether it's just JOTs, those JWTs, or other types of token schemes. And hopefully what you've seen with customers is that they are actually using either JOTs that are well configured, or even sort of the signed requests. That's the model that AWS has, rather than just HTTP basic or HTTP digest. Has the authentication at least gotten a little bit better there?
Yeah, I think by and large, the authentication schemes themselves, if properly implemented, tend to be pretty good. And it's really going to depend on your use case. So if you're using a consumer mobile application or even like an enterprise application where you have a user that's basically connecting into it, there's a good chance you're probably going to be relying on something like OAuth 2 or SAML as really kind of that mechanism for at least validating or authenticating the end user. And so ultimately, those types of protocols and those types of systems tend to work fairly well. I think the bigger challenge with APIs always ends up being more of the machine to the machine communication. And in particular, one of the big things about machine to machine communication is that those tokens and the IDs themselves, or the actual secrets between them, they often get stolen. There's plenty of instances where developers have accidentally just checked those tokens into source control, and Git never forgets. And so it's really easy to go back and find in the Git log basically those instances of the keys that are in there. Or people are storing them as environment variables, and those environment variables are getting filtered out basically in one way or another. And so it's not necessarily the authentication mechanism that I think is a big challenge. It's the tokens themselves. And relying on short-lived tokens that you have to refresh, those are some of the strategies that we ultimately will see being used for solving authentication for APIs.
Nice. And hopefully the story behind rotating, managing those tokens, managing those secrets is improved, whether we're talking about just cloud native types of environments, all the cloud service providers having APIs of their own to be able to manage that, or at least expectations that here is a mutual TLS, here's just a mutual token to demonstrate authentication or demonstrate that identity, so that, like you said, attackers don't necessarily need to get root, they just need to get access to a system. And if it's a API token, game over, because then they can get into the service, into the data.
Absolutely. And this is ultimately, I think, where APIs become a little bit more interesting to us as an attack vector themselves, because one of the things you have to really kind of consider about an API is that it's by definition really kind of designed as being a data query language effectively. It's a data query language that you happen to be exposing and accessing over HTTP. But the core thing is that it's actually exposing the underlying data, and it's giving developers a really easy way to be able to query that data and access it. And so this is part of the reason why we saw the changes in the OWASP API top 10 to be really focused on around authorization. Because ultimately, by giving and exposing a query language externally in something specifically that's also stateless, it made it very easy for attackers to go in and start actually trying to look and query resources that they shouldn't have been able to look for. And so I think that's ultimately one of the bigger challenges that we'll see, at least initially, with a lot of APIs, and where a lot of attackers tend to look.
So that's a really interesting way to think about it. And one of the things I've been trying to wrap my head around for the last few months, or I guess longer, but if you think about GraphQL, that I think in almost everyone's mind is most definitely a query language that's been exposed over some sort of HTTP port, HTTP protocol. But I don't know if I'd made that leap myself to actually, I don't know if I'd say admit that a standard JSON API is actually more of a query language. I think there's things you can do in there that aren't necessarily data related, but I think you're probably right. And then that's what we're using it for more and more and more nowadays.
Yeah. And the way that I've kind of rationalized it and thought about it is, let's take SQL, because SQL is, of course, kind of the most common, data query language that actually exists out there. You have selects, inserts, updates, deletes, those types of actual DML statements that you're going to use to modify and to really work with the actual data. When you look at RESTful APIs, you actually have those exact same things. They're just masked as the actual HTTP verbs themselves. So they're going to be get, posts, puts, and deletes, but they're doing functionally the same things as selects, inserts, updates, and deletes. And as we've now moved towards more GraphQL-based APIs, some of the problems that GraphQL was really solving was that developers, by and large, just got tired of writing very specific interfaces for accessing certain subsets of data. And they just basically said, well, wouldn't it be better if we could just expose this API outward, and then the client could tell us what data it wants in return? And effectively, what we've developed is really a version of SQL that is a little bit easier to expose out to the web and out to different types of developers.
And I think, to your point too, it's not that this different version or better version of SQL doesn't mean that we should then immediately start thinking of SQL injection, because it sounds more like that tie together of here are all the clever ways of just exploring the data. And we established that you might have an identity, but do you actually have an authorization to explore the data? And I'm going to guess that's where some, here be dragons, because especially if we're talking about microservices, where are the controls? And do we have some transitive trust issues between a bunch of these microservices that microservice A trusts B, therefore B just says, oh, you asked for this data? Sure, I'll give it to you. But they're not necessarily doing it at the granular user level to figure that out. So, I think that's kind of the direction you're going here. Tell us a bit more about, how you see the good and the bad, if you will, of GraphQL and where those dangers are.
Yeah, so I think for at least externally exposed GraphQL APIs, it's relatively easy to think about kind of the threat model of, well, we have to be very careful about what type of data we're exposing here. The way that GraphQL allows you to really compose your queries, and specifically asking for not only subsets of data, but effectively joining other types of data together. I mean, one of the major benefits and problems that it was solving was, instead of me having to basically make 5 different requests to fetch, all of these different resources and then basically do these joins locally on the client, you could basically go and just say, well, wouldn't it be better if the client could just ask for and try to do these joins directly in a single query and reduce the number of HTTP calls and data that we have to transfer back and forth? And so for those types of externally exposed applications, I think a lot of times developers will at least I'm hoping they'll take a little bit better of a kind of put their hacker hat on, and think about, okay, what are the ways that this can be really abused? The bigger problem, though, is when you start getting to those internal APIs, because generally speaking, there's that implicit trust always around anything that's released internally. And people just start going, and developers will expose them to the various teams around the organization. And they'll basically say, great, here's this interface, this GraphQL API that we wrote out or that we built out. You can go and you can access all the customer information. And, for the business team, they can go and query the data without really having to go and bug the dev teams. And now what this ultimately means, though, is we've taken really kind of like a SQL-like interface. We've exposed it internally only, but at the same time, there's no better controls, or there's no controls really over the amount of data that can really go and access that. And so I think this is where, we talk about the good, the bad, and the ugly. This is where I think we get into that ugly category of, if we look at large data breaches that have happened in the past, where we've had, millions and billions of records really stolen and exfiltrated from organizations, those, generally speaking, have come from databases or, data lakes or those types of systems, or even, file stores. GraphQL APIs, I think, are really kind of that hidden, almost like the really, really big bomb that's just waiting to go off in a lot of internal organizations. And I'm going to call it right now, because we're getting into prediction season, that we're probably going to see a very, very large internal GraphQL data breach, because credentials get stolen, they get access to that data, and then ultimately we're going to have the ability for an attacker to just get in and basically pilfer data through the interfaces you've exposed.
Now, in the spirit of trying to defeat your own prediction, are there ways that developers can turn to try and make this situation better? And here I'm thinking of, we talked a little bit about authentication, talking about JOTS, OIDC, SAML. So there are common frameworks. There are, some standards, some protocols that are, I'll say, relatively easy to adopt, if not necessarily understand, and implementation mistakes happen. But what about the authorization side of that coin? How can a team go in and not be the one who ends up on Peter's prediction for 2022?
So there's a couple things on the authorization side, and authorization is its own big topic. I mean, it's really challenging, I think, for a lot of organizations, because authorization lives so closely to the business logic of the application itself. And so ultimately what ends up happening is pretty much every single development team rolls their own authorization system. Most of them start with very, rudimentary and crude systems, just based on, we've got these different roles of users, and they'll use standard RBAC. A little bit more, up and coming models, or at least models that are more mature, are going to be more attribute based access control. In particular, though, I think one of the big things that I've seen over the last couple of years has been the development of really kind of open source authorization frameworks and systems, as well as even publications from other organizations that have talked about exactly how they built their authorization systems. And a couple of the big ones that I'll throw out there right now are, there's a language as part of the Cloud Native Computing Foundation called Rego, or it's part of the Open Policy Agent, so OPA. And this is maintained by a company called Styra. And it's an excellent way of basically building out a resource-based authorization system. And it allows you to basically implement this authorization check logic in a variety of different purposes as a library or as a proxy in front of the code, or even in instances where you're running in kind of a microservices environment as a sidecar. There's a couple other languages out there. Another one is called Polar. It's developed by a company called Oso. Smaller startup, but I'm starting to see a lot of chatter about it on Stack Overflow and the various other developer systems. So kind of cool to see those types of systems being built out more and exposed, because being able to centralize those authorization systems, being able to use a framework that's actually well architected is really kind of a big battle with that. If you want to talk about really good architecture of authorization systems, Google, they've published papers on Zanzibar, which is their internal system that they use across all of Google to basically manage authorization across, Google Docs and everything else that you basically touch in there. It's a really, really fascinating read on how to build and actually create an authorization system at scale.
That's interesting. The OPA one in particular is like, so from my container background, I'm used to seeing OPA. First, I was seeing it used to actually, control access around whether a container should be allowed to run in a Kubernetes cluster or not. Mm-hmm. At my last gig, we were using OPA to actually write some of the rule set. Well, the rule set policy which we were using around scanning clouds and ISE. Mm-hmm. So it's interesting in that OPA itself is, while I think a lot of us think of it in one of our particular little boxes, they've actually done a good enough job with the language it can be used across many of these things.
Yeah, it's abstract enough that it actually is able to be applied to all of these different use cases, which is what I think is actually the genius of it itself. And even on their website, or in the OPA documentation, they talk about some of the use cases of how you can implement it for protecting HTTP-based APIs. And while, some of the companies and the main backers, they were more focused on container security and orchestration and, the Kube API actually in a lot of instances, it can be used and extended for these other use cases, which is great to see, and I'd love to see more of it. Probably the most popular talk that I've seen around this was Atlassian actually implemented their authorization framework using it. And there's a couple of videos that are out there, and they were reaching some pretty impressive scale based on the back of it. But ultimately, from a high level, when we think about what they implemented, it focuses really on four main things. You've got a principle, so basically the person that's trying to do something, the action that they're trying to perform, so kind of like those get, post, put, delete verbs that we were asking about or talking about before, which is really just CRUD operations, the resource that's being trying to access, and then as well as any conditions that need to be applied to that. Like this person can only access this from maybe United States because we've got geolocation requirements for it.
And all that sounds like as well that it's building up the case for call it policy as code, since everything is now something as code these days. But I've been slightly facetious, but to reach the scale that you're talking about and to be able to lint it, just be able to query and say, have we over permissioned something? Hopefully, it's a lot easier to reason through if we've got those four principle or those four components in expressing this language. So I'm kind of curious too. Where was my brain going? Just in that aspect of seeing how where does AppSec come into this? Because a lot of what we've described actually is the DevOps team making those design choices, those architecture choices. We're going to go with microservices, GraphQL to tie them together. That has a lot of performance, a lot of very positive, can reduce latency, a lot of just very good engineering principles behind it. But AppSec can come along and say or do what? Is this a great case where AppSec is actually strong on the engineering and they're going to help just implement OPA, for example, or is there some other type of role for them to come on and help this type, the API engineering?
Yeah, I think if you're an AppSec team and you come to the engineering team and you basically say, let's go and swap out the entire authorization system of our production applications, and the app engineering team's not really looking to do that project at this given time, they're going to kindly tell you to GTFO basically, which it's a huge undertaking, which is why organizations don't do it. So, but there are things that you can do kind of ahead of time, and I think if we go back to kind of this notion of API security really kind of being a data security problem, for an AppSec team, I think what you can do is you can start to apply some of your data security types of practices to your APIs, and that's going to actually get you there, at least from kind of a understanding what your attack footprint looks like, understanding at least if someone is trying to access too much data. And really where that starts is by understanding not just what your attack surface is and the data that's going over it. So kind of that discover and classify kind of aspect of your data security programs, but then taking it one step further and saying, well, let's start auditing all of our API queries that we end up seeing. And, in the case of a RESTful API, they're probably going to all look very similar, and you're going to be able to really kind of throw away a lot of it, or at least kind of batch a lot of it. But when you start getting into GraphQL APIs, especially where they tend to be highly irregular or custom, basically, depending on the type of resource that's being requested there, this gets you a really far along in the process of at least understanding how resources are being accessed, who is querying what data. And then in particular, I think when we think about data security, one of the most important aspects is always, if I'm auditing a SQL database and I want to know if anyone is performing any malicious SQL queries or trying to expose or extract large amounts of data, probably the most important thing that I want to look at in there is the number of rows returned. I want to know how many records are coming back. And you can do the exact same thing looking at it from a GraphQL perspective, or even a RESTful API of understanding how many resources are actually being returned with each individual query.
So the OWASP top 10, for example, I think had like an insufficient logging, which is a reasonable recommendation, an observation about things that can go wrong, but it's also unfortunately pretty high level and tends to be so vague that it's hard to say, okay, well, what does sufficient logging look like? And I think you just described a couple examples of what sufficient logging should be, but are there ways too, if we, as the AppSec person coming into the room, I've already said and failed perhaps to say, oh, we're going to adopt, Rego. We're going to recreate the Zanzibar model, and not going to accomplish that in a quarter's worth of engineering effort. Can I come in and do something similar with, being able to have some better traceability or auditability within the application?
Yeah, and this is, I think, the great thing is, as the security team, you can come in the room and you can start advocating for observability tools, and you're going to get the DevOps guys over there, and their ears are just going to light up, and they're going to say, yes, we've been, clamoring for observability tools for, years. And this is actually one of the great things, improvements. We want to talk about the good of API security. This is one of the great things that I think has really evolved over the years, is the improvement in observability tools and the open source kind of, or at least, standard frameworks around it. So you have part of the CNCF as well as you've got things like OpenTelemetry, which by and large, most of the community has kind of really kind of started to go and focus on. And while it was originally designed more for let's troubleshoot and understand where there might be latency or bottlenecks in our microservices architectures, one of the great added benefits to it from a security perspective is it basically implements full data tracing across the entire request. And you're able to understand not just what those requests are doing from a latency perspective, but also really from like a data lineage perspective, which APIs are effectively being called by individual front-end requests. And so by having that and those tools, that data can give you that audit trail that you really need, at least initially, as you're looking for it. And then you can start, of course, going and implementing your own custom, middleware or resolvers, whatever you want to call them, depending on the type of framework or API that you're working with to give you more data. But it's a really, really good starting point, I think, for a lot of organizations.
No, and definitely a better story. I love how you put that in the sense that this is something that's already going to help the engineers. And oh, by the way, if we do this one more thing, or if we just broaden it a little bit, we're going to get some great security benefits out of it too. Sounds much more, much friendlier way and more successful way of approaching that.
Absolutely.
So I think you've talked a little bit about the future. We'll possibly see that big data breach from compromised tokens. We've, I think to help bolster your case for that, we've also seen recent supply chain attacks that have targeted environment variables because that's where the tokens are. So, it doesn't necessarily seem like you're, going too far out, or we won't necessarily be too surprised by that. Looking ahead, or maybe even for that matter, looking to the past of things we could learn from, are there other aspects you'd really want to highlight, or, as cautions for, or things to learn from, or to try to accomplish for teams that are diving into API security, and hopefully from a fresh perspective, or even if they're trying to get away from legacy applications?
Yeah, ultimately, I think one of the biggest things that I just want to emphasize is, and we talked about this very briefly in the very beginning, is if you're going down this path and you're just saying, okay, APIs, we've really got to get our hands around it, the very first thing is don't throw away your entire strategy. Like I said, about 70% of what you're doing for web application security will still apply for API security. You just kind of have to cover this new 30% gap. Some of those things will be, fairly straightforward and not that difficult to really manage. So great examples are, one of the things I strongly advocate for is if you're developing RESTful APIs, one of the great easy things you can do is starting to advocate for design by contract. And so basically what I mean here is if you think about APIs are interfaces, and one of the big things that developers love talking about is really coding to the interface or treating your interfaces like a contract. And if you think about how you expose those external APIs out, one of the great things is a lot of times now there's going to be specifications or schemas that are really kind of associated to it. And the most common is going to be the Open API specification, or previously known as Swagger. And so a great strategy that you can use to implement not just really good development hygiene, but also really being advantageous to do kind of that input validation type of aspect is to do more of a design by contract based on that schema. So as an example, at Imperva, what we do is anytime an API needs to be exposed externally, it has to be documented first in the actual schema. So the developers have to have that really good, robust documentation that is always forgotten or an afterthought in order for us to actually expose that API out. If it's not documented, then it doesn't get exposed. That's pretty much where we stand.
Yeah, I'm laughing because it sounds like a good point that I forgot about, the idea that, well, this will just be an internal API, and a couple months later, there's a product decision to say, hey, this is a great B2B SaaS API. Let's expose it. And oops, we didn't document it, or we didn't do something like that. I'm curious, are there some other cautions? Help jog my memory, or help me expand my list of, are there other things that should be careful of on that internal, call it that soft, crunchy interior of APIs?
Yeah, we talked about it just very briefly here, but ultimately it's not just understanding the attack surface, all the APIs that are out there, but it's really also understanding the data types that you're exposing. In particular, I think APIs always tend to be overexposing data. A lot of times, especially on the internal side, developers will go in and they'll basically expose an API and they'll say, we're going to give access to all of this data because it's only for the internal applications and they might need it later. And I don't want them to come back to me and, ask me to change this or add some parameters or fields or things like that. And so they just, expose lots of data. And then, like you said, 3 months down the road, someone basically just says, well, great. Well, let's just go and expose this API out externally. And sure enough, we started exposing lots of PII or EPHI or, all the different types of sensitive data that you might have out there. And so those are really the kind of those bigger risks that you have to think about really kind of from a risk management perspective is what are the actual data types that we're exposing? So not just what are the API endpoints and where are all they, also understanding that sensitivity of the data helps you to basically make those decisions and better understand when something inadvertently becomes exposed externally. Because if you go through kind of some of the big data breaches that have happened in the last 2 years related to APIs, that's probably one of the biggest ones, actually, where sensitive data was just accidentally exposed out through public APIs.
Yeah. Now I know we've unfortunately passed. October's behind us. But still, speaking of ghosts and goblins or things of the supernatural, you're talking about a lot of the API security as a data security problem, and what you're just describing sounds a little bit like having a data inventory or even a data flow diagram, which once again are easy to describe, but are these creatures, have you seen these creatures in the wild? Have you seen teams successfully develop these though?
Yeah, I'm going to say yes and no. Okay. I'd say like any other kind of like inventory or asset inventory, there's always kind of like well-meaning and well-intentioned efforts, and it's always ends up being about like 80% accurate. And unless you're really kind of more proactively keeping up with it and basically regularly scan, not just treating it as this point thing, or you're taking an approach where the only way something gets exposed externally is we do have the documentation and it's basically fully uploaded, and that's kind of our gating principle, then there's a good chance that it's probably not going to be up to date in there. We do see more and more people kind of exposing and building out centralized data catalogs effectively for at least RESTful APIs, because one of the big challenges, of course, with RESTful APIs was that, unless you had access to that documentation, you were basically, just pointing at a black box and trying to guess what the parameters and resources were. And so there are lots of developer tools out there where now they're kind of decentralized API instances. Like, probably the most common one that people will be using is like Postman, just to be able to share the collections out and things. But the accuracy of those, because a lot of times they're going to be based on what developers wrote, is going to be a little bit suspect.
A little bit suspect. That sounds like that should probably be a theme of application security. Quite honestly, maybe that'll become our motto. You've made one prediction already. Looking again, do you want to add to that predictions, or just looking forward? Do you instead of a prediction, perhaps a preventative measure that you'd love to see teams adopt, or something that they should just keep their eye out for as 2022 starts to roll in?
I think ultimately, as more and more organizations are at least making, there's a greater level of awareness, I think, around at least like these types of issues with APIs and the challenges that teams are facing. I think the technology and the tools, especially for security teams, are getting a lot better at being able to detect and understand that. And, in particular, I'll even say it from Imperva's perspective, when we started looking at and thinking about API security really through that lens of data security, we kind of realized, oh, wait, we have all these other algorithms that we built for, detecting bot traffic or detecting data breaches through a SQL database that can actually be applied to some of these problems. And so I think from a defense perspective, the technology is getting a lot better and there is more hope. So you don't have to go and implement and try to build this stuff from scratch. But ultimately, it's really going to be just a matter of teams kind of getting started on this journey and thinking about really kind of the new problems that they have to go solve with API security. And it can be a bit challenging. I think they're daunting for a lot of teams, especially if you don't come from this world of being an API developer and really understanding kind of the nuances of them.
No, I think that's and that's a great way. We'd love to have you back. So when when that big internal data breach happens, hopefully it won't happen until 2022, but who knows? We'll definitely have to have you back and chat with us about that and do some analysis and once again a constructive postmortem about how teams can better protect their APIs.
Thank you. Yeah, I would love to be back to chat about it, and just go take a look at some of the bug bounties that get posted out there, and I feel pretty confident in my prediction just based on what I've seen out there already.
Well, I feel pretty confident that we've got some great information just now about securing APIs. So I just want to say thanks once again, Peter. I want to thank John as well and everybody who's been listening. If you'd like to hear some more insights from Peter, go check out episode 159 back from July 26, 2021. And if you'd like to learn more about Imperva, visit securityweekly.com/Imperva. And with that, we need to take a quick break, and then we'll return with news of the week.
Whether you need to manage bots, protect cloud applications at runtime, stop form-jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Software supply chain attacks are continuing to expose vulnerabilities in organizations around the world. The time has come to focus your efforts on security for your software packages. Cloudsmith is the only cloud-native software package management solution for your enterprise. With Cloudsmith Continuous Packaging, you can securely deliver software across the globe and mitigate potential threats from entering your supply chain. With over 23+ formats supported, Cloudsmith is the solution that engineers choose to safely deliver all of their assets. Reduce unneeded downtime and deliver with confidence. Start securing your software supply chain today by visiting securityweekly.com/cloudsmith.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, a Discord server. You can be chatting with us live right now, and you can also follow us on social media and our other streaming platforms. Additionally, Security Weekly Unlocked will be held in person this December 5th through 7th at the Hilton Lake Buena Vista. We'll have keynotes from Alyssa Miller, John Strand, Leslie Carhart, and Dave Kennedy. Visit securityweekly.com/unlocked to register, please, and check out our exciting lineup. John, this brings us to the news segment now. It's also November 1st, so I did want to point out that it is Samhain. The festival that everyone sees written down, but nobody knows how to pronounce. But it's also when the boundary between worlds is very thin, much like the boundary between AppSec and DevOps should be very thin. But in the last segment, as we heard from Peter, one of the ways to make that boundary thin is to find engineering principles like better observability that are helpful to engineering teams, to DevOps teams, that can also then have some security principles or some security properties then tagged onto them. So I know I'm making this up as we go, but I'm not sure if there's a particular boundary between AppSec and DevOps that you would love to see broken down.
I'm going to go in the opposite direction on that one and say I think we're getting too close, at least in some cases. By which I mean when people embrace DevOps and embrace IAC in particular, the idea of having one stack where everything is put together isn't necessarily a good idea. I've got a few blog posts I'm working on that are going to come out in the coming weeks. Mostly around the idea of when we see code examples out there, like on, let's pick a company that I don't know. We were talking about OPA, so let's look at OPA. Probably not the best example, but I'm going to run with it. Some of the code examples we see out there don't actually include errors in them, or how to do error handling properly. So that's sort of one of the blog posts. But to bring it back to this a little bit, the concept of just because we can do everything in a monolith in a single, say, CDK or Terraform or pick your IAC, doesn't mean it's a good thing. Example being, if you've got a single IAC, which, it brings up your databases, sets up your authentication, sets up your SSL or TLS and your gateways, your API gateways, and deploys your Lambdas and does all everything's perfectly and it works great. What I've seen over the weekend is there could be situations where that stack gets into an unrecoverable error, and all of a sudden you have to actually roll back completely, including rolling back your database. Luckily, I'm not doing this in prod yet, but the thought occurred to me. I'm like, that's scary as all get out. And I know my co-founder listens to this. So, hey, Chad, I know you're not getting enough of my voice, so here's more of my voice. But that's something to stop and think about, right? So it sounds like a great idea to us at first. Let's put everything together. But maybe sometimes we need to sort of go, okay, let's have an actual infrastructure part and a code part. And that'll probably allow quicker deploys too and things like that. But so I think that's just my general response to your off the cuff question there is maybe not necessarily break down barriers, but sometimes we need to think about what we should or shouldn't be doing. And should we be going for a single state of perfection? How about that? Or should we maybe have something a little more tiered?
There we go. No, and we'll look forward to those blog posts. So definitely let us know. And if they come out before one of our episodes, drop them in the Discord channel for everybody to take a peek. Because it definitely sounds like we're going to have to celebrate the AppSec DevOps equinox is the direction you're going. The other direction we're going, Mr. Kinsella, is seeing some of the same articles. It's interesting, what stands out to each of us as we go and explore what's happened in the week in application security. And one of the things that caught both of our eyes, obviously, was this concept of the minimum viable secure product that Google, Salesforce, a couple other companies are just trying to put together. What does a checklist look like? And it's a bit of a combination between a checklist of a broad instruction of, have some good business processes, but they don't necessarily say exactly the details of what the processes are, how to implement them. But then it does get into some things like password policies, some very prescriptive and detailed recommendations. So I want to throw back to you. Tell us a bit more about why this MVSP stood out for you.
Thank you. You talked just long enough to let a really noisy truck go by outside. I appreciate that. And so do our listeners. So MVSP, Minimum Viable Security Product. This came out last week. It was on both our radars. It's a combination, it's a result of a combination of several companies working together, Google, Salesforce, Okta. It looks like it was based off something from, I think, Dropbox. But end of the day, here's what they're trying to do. I'm a large company. That means, imagine I'm a large company. That means I've got not a lawyer, but not a room, probably a floor filled with lawyers, right? Just in the purchasing department alone that are wanted. And they usually, for them to be working efficiently, they're probably going to want to work with another large enterprise that also has a team of lawyers. And then they know each other, their language they're speaking and all that type of thing. But these companies, hey, they used to be small at some point. They'd love to work with the smaller companies, but they still need to have some level of, how would I say, controls and regulations around what that engagement looks like. So if you want to purchase, if you're Google and you want to buy something or use a product from a small startup, how do you know what they've done for security? We'll focus on security for right now, but that's sort of the idea, right? So what they did is a few of these guys got together and they came up with this thing called a minimum viable security product. So what do you need in that product that at a minimum for a company like that to purchase and use? It is 4 parts. It's split across business, application design controls, application implementation controls, and operational controls. So it's fairly short. They made some interesting choices. I think is what caught my eye about it. So at first, if people go to the show notes, you'll see my snarky comment of another checklist, which it sort of is. But again, like I said, interesting choices in here. 2 caught my eye. One was the password policy. So let's see, what do we have? Well, first they want to support SSO, which is interesting. I mean, definitely something that's needed, right? When you go work with a larger enterprise, you have to support SSO, but calling that out was interesting. How the passwords are stored and some of the details around it, requiring email verification for password change. Don't use secret questions as a sole requirement for resetting a password. Password length, characters in the password. So it's interesting to see that was something that they cared enough, particularly that part of AppSec or security in general, to call that out in that much detail. And then the other one in here somewhere, under incident handling. Notify your customers about a breach without undue delay, no later than 72 hours upon discovery. That's quick. So I mean, that's, everyone nods and smiles and will agree with this, but in real life, what will come back to, and I think the interesting part is, are there teeth about if something is, if there's a breach in this? This isn't. I don't think this is a license. This is a license. It's not a contract. So I'm not sure what happens if there's a material breach of this. Like if it takes longer, what actually happens? I think it's just supposed to be these are what we want you to see you have. Because part of the question then comes, well, is it from the time you knew about it till the time it happened? Or, I mean, I think a lot of places, even once they know about it, they can't get a list of people to contact together in 72 hours. So that one's sort of interesting. But that's the overall thing. A lot of people have been talking about over the last week. Surprisingly so to me. I've mentioned to a few folks, and I expect to have to explain it to them. They're like, oh, yeah, we saw it. So, once you put Google and Salesforce on the top of something, it sort of gets out to people pretty quickly.
Yeah, I think, for example, some of like that 72 hours can also actually come from GDPR, which I believe does actually have 72 hours. I can't quite remember the CCPA, California's version of data protection, but there are some external requirements that come in there that do force about what is a breach and have you notified users of a breach, unauthorized access of their data in a timely manner. And I think for me that stood out from this is the idea that we can either go sort of that vendor security checklist, send someone like Cloud Security Alliance has, I think, a multi-dozen questionnaire for this, and they also have the light version that I think is maybe only 1 or 2 dozen questions, but that's sort of saying, are you doing this? And this checklist is coming from, just go ahead and set up your application this way, or design your application this way and operate it in this manner. Mm-hmm. And the things that stand out to me are, so it does mention HTTPS only, which it's unfortunate that has to be, that actually has to be commented on in this day and age, rather than it's just assumed as a baseline. And that's where I hope that SSO angle is going as well, because from an enterprise perspective, rather than worrying about the password policy for all of these, this constellation of SaaS applications in use by your org, you just have your own SSO backed by your FIDO key. For those of you who are listening in to the one word that I was repeating every single episode all of last month, those are great protections. And I think the other thing that stood out to me that I would also just kind of 2 things. I lie. Security libraries. It is nice to see just that push towards frameworks, ORMs, UI frameworks, to get rid of SQL injection, cross-site scripting, for example. They're talking about using things like React, Ember.js, or things that make it really hard to introduce vulnerabilities. And the encryption. What it doesn't call out on the encryption part that I would kind of emphasize here is, how do you handle encryption for your customers? Meaning, are you offering customer managed keys? How, is your encryption all or nothing? Does it actually support multi-tenancy out of the box? And does it have different designs, different controls, or just different threat models around the multi-tenancy aspect there? So again, it's a great thing to start with. Would love to see, I would have a couple tweaks here and there perhaps, but basically if my vendor security questionnaire could be, do you adhere to the MVSP? That's much easier than going through the CSA. Not to pick on them, it's a great checklist, but trying to go through a few hundred questions of a vendor security questionnaire.
Totally. And I think, remember also this, at least the way I'm thinking of this, working with a lot of small startups, I've tried to put together a list of like, how does a small startup, here's the things you need to worry about. But I think this is a really great job of it, right? Like, I mean, if you go to your average 50-person startup and say, show me your data flow diagram, no, ain't going to happen. But that's a super important thing, not just have externally, but it's going to help you internally, new people onboarding, all sorts of things. The one you just mentioned was interesting to me, the using a ORM. And I think with that one, I was going with the spirit of the law, not the letter of the law, because I've been bitten by ORMs in the past, so I don't like them. So when I can, I don't use them. But I will use, and again, this is me saying this, not your average person, right? Average developer. What I will do is use a SQL library and make sure all my queries are using parameterized, they're parameterized queries, and things like that. So there's other ways you can do the same type of thing without using an ORM. But I think this is one of those things that if you're able to show a case for that, it's the spirit of the law, not the letter. But yeah, it's a fun thing for folks to read.
No, wonderful point. And now I'm going to have to start introducing you as John Kinsella, not your average person. So thank you for that soundbite. I appreciate it. What we will is, speaking of sort of ORM, Ruby is one that comes to mind in that, and how they handle, active record, making SQL injection more difficult, hopefully impossible, but also some Ruby code. This is my segue into another one of our articles that's a completely different direction about in Discourse server. They're using the Amazon's SNS, using a webhook for that basically is just a few lines of code, which is where this researcher was looking at to explore and discover vulnerability. And these few lines of code are basically saying, here is some arguments to pass into a webhook. They need to be signed, and they're going into an open function that is intended to receive the URL, whatever your webhook has subscribed to, something like that. But open, as as many developers know, can also open file handlers and do things like pipe into commands, which leads to remote command execution. And what was really neat about this is that it's one of those articles that it's fun to read through, because you see a researcher who has an idea. They see a code. The code doesn't necessarily have a code smell to it. So it's not, at first glance, clearly insecure, but it's more of, how might I pull this apart? And they walk through about what checks were in place to verify signatures of how these requests are supposed to come in. It's looking and seeing how PEM files, the certificates essentially, are being retrieved, and where are some areas that could drop one of these certs into an AWS environment so that they could actually have some arbitrary signing into getting some arbitrary command execution. So really fun journey. And one of those things that is actually using some cloud native services in probably a very good way. They just sort of made a few fundamental mistakes. So maybe this is also one of those areas where we do need some AppSec to be separated, have a bit of a stronger boundary between AppSec and DevOps. So we have some good AppSec threat modeling and some poking around, if you will, to use the technical terms of these types of environments. That's how I was trying to tie it back to your initial comments there, John. So not sure if there's something else about this that maybe I missed or that you'd like to highlight. So what did you think of this SNS Discourse?
Yeah, no, I think so there's the first part is I made noises, when some of us look at that open, where's the actual line, open, oh God, it's so far up, subscribe URL, and you think about what that's actually doing, like, oh, that's bad. And yeah, but what's actually interesting around this to me is, again, it's one of those areas I don't think we spend enough time focusing on, but actually showing people how do you, it's one thing to say, just, filter the input or make sure you're validating what you're handling. And there's libraries to do that and things like blah, 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 blah. Hand wave, move on. How often are we actually doing this type of thing, right? So I think at least in Go, and I think probably in most languages, a slightly different degree, but like the amount of actual, your LSC count, the line of code, which are just purely doing business logic, probably not that great, right? In this case, dude wants to open a URL. Okay, to send a message, but the number of lines of code you have to do before that somewhere, that sort of pollute if you're just looking at it in one screen, of doing either validation or some sort of cleaning or making sure that's legit. It takes up more work than the actual work you're trying to do itself. And I think it's good so when I saw that in here, that actually really caught my attention. It's like, okay, cool, this is what people need to see. You need to verify HTTPS, where it's posted from, look at the PEM. And going through and doing all these type of things, I think that's sort of the important part of this. So really great from that point of view. When you were talking through, what I'm sort of thinking about things like this, it'd be a neat experiment for users, for our listeners. They're not users, they're listeners. To be able to think about when you see something like this, when you're doing code reviews on with your coworkers' code or staff or whoever, how can you actually try to take an example like this and bring it back out into the real world? And I don't know if it'd be worth the trouble of actually going and maybe finding an open call in your code, or if you're trying to do something with SNS and look at how you handle it. But that's always the interesting part here to me. It's like I'm happy to provide entertainment and make snarky jokes, but how can people actually bring this stuff back and make it useful in their own environment, I think is super important.
It is super important. I think we'll need you to keep harping on that, because we have yet to implement RFC 3514, which would have made all of this type of security just much easier. So there's the Easter egg for our listeners. But you also set up, I think, a great segue into the NCC group published a public report on the security assessment they did for WhatsApp. And again, I pulled that out of interest and just seeing what was the, what is the protocol and encryption model behind something like WhatsApp, but also pull it out in that very spirit of what you were just saying. Here's how to learn from how other people create threat models, how other people communicate or conduct security assessments, because you might not be someone who's implementing end-to-end encryption, but you probably are handling keys somewhere. You might even be, depending on your environment, depending on your requirements, the compliance obligations, you might be interacting with HSMs. And so looking at a report like this, I think can be pretty informative from a couple different perspectives. In this case, there was nothing too earth-shattering, I would say, in terms of their findings that they pulled out, and I threw some. They're talking about opaque and some password authenticated key exchanges, which are really cool, and basically ways of blinding the servers to what users' passwords are. So that's one of the ways to help protect secrets as well, user secrets. And I threw in just a link from a Cloudflare blog that's also talking about some the opaque protocol and some of these other opaque protocols. So just kind of offered those up in the spirit of learning more about different schemes and how they might apply to your environment. And the one other thing that I'll highlight before I turn the mic back over to John once again, and making sure no trucks are going by, is this also talks about ceremonies, and the idea between ceremonies are a concept that actually came out of some Microsoft research that say you have protocols, but you also have people involved with protocols and people involved with the process, and they just kind of were using the term of art as a ceremony. And that's important when you're handling encryption keys, when you're interacting with things like HSMs or building trusted code, because you want to make sure that, and here we go with the bingo card, your supply chain or your end-to-end process of from code to deployment is a trusted chain of events. And this becomes extremely important for things like having confidence in end-to-end encryption. So a great, a neat security assessment, a great way just to perhaps broaden some of your threat models around encryption keys. How can attacks perhaps be targeted, and what to worry about when you're, for yourself, for your own environments, just dealing with encrypted data. So that's the broadened aspect there. I've filibustered long enough, so hopefully traffic has died down, John. Let's hear what you have to say about this.
The trucks are gone. Everyone's awake. They've no point for them to make noise here anymore. Everyone's up. Yeah, so the first thing, what was interesting around this is if you look at the scope for this, it's very scoped. 5-phase, just to sort of go really quickly. Phase 1, end-to-end encrypted backups. That's all they're looking at in phase 1. Phase 2, as you said, is opaque. 3, HSM and key management. Nothing but a phase on that. And then 4 and 5 are retesting after it's a recheck. For those who don't know, usually when you do a pen test or some sort of a security test like this or an audit, you go through, do your work, give it to a customer. They go scratch their head. There's usually some big meeting with like everyone around the table. And then if in some cases they go off, do their work, come back and have you retested. In other words, have they fixed the things you found? So that's 4 and 5 is looking at the results. So it's a 3-phase pen test, or excuse me, a 3-phased audit focused really on the encryption of WhatsApp that that 3 guys spent 35 person days on. That's a fairly expensive report for, let's be nice and say they're $1,000 a day. They're more than that, right? But these are NCC. These are some of the best guys out there. They're not cheap, even after price negotiation. But so the point being, this is a really interesting review to look at from that point of view, that you're actually seeing a security a product that's been designed for security or for privacy. After 3 guys went and poked around at it, what were they able to find? So to me, that's really interesting, right? This was, you've got probably some of the best people on both sides of this working on this product. They were still able to find some issues. Most of them they've gone and taken care of. The low and info level ones, as usual. The WhatsApp guys said, yeah, we don't care about those. We're not going to deal with them, but everything else they fixed. So I think from that point of view, it's really interesting to go through and read this and actually see what could people find even after it was designed with that usage in mind. So in other words, the other way to look at this, there's always space for all of us to improve. But this is a good example of both of these guys do this stuff every day, day in, day out, and this is sort of what that type of thing looks like. So that's sort of cool.
It is cool. And I'm glad you mentioned too kind of the responses, because one of the other reasons I like to highlight reports like this or the blog post from earlier is good examples of communication and communicating security. And in this matter, I also wanted just to point out, the security isn't necessarily binary. A lot of things aren't binary except the code that we're running on our CPUs, perhaps. In here, you see some of the reasoning behind why this is a high, medium, and low finding from NCC Group. And there's a table of responses to the findings. And this is just a good exercise to read through and say, this is a risk approach, saying we deem this a risk that we want to fix, or we deem this an acceptable risk for these other reasons. And there might be mitigating controls. It might be our threat models are slightly different, or it might be that there are just other other restrictions why we can't follow through on a particular recommendation. So I think that's also really good to understand and learn, so that when we talk about checklists like the MVSP, we're not looking at the checklist just to say yes, 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 no, no, no. It's more of, have you paid attention to the context? Have you thought through the threat models behind it? And maybe some things just don't have to be fixed. So
a quick comment in there. We had someone from Twitch, I guess, respond back with a WhatsApp security ? Don't use the app. Easy. I personally agree with them. I deleted WhatsApp off my phone. I'm working with enough people in Asia that I might actually put it back on with another username. But whether you agree with the policies behind, and that's not security, right? That's privacy. So 2 different things there. Right. I think WhatsApp does a great job with security. Privacy we'll leave for the guys on the other Security Weekly privacy show, because I'm just dodging that bullet. But yeah, that's some things we gotta keep in mind, right? It's one of the biggest issues we have with Facebook right now is they've done some really amazing work about what we cover week in, week out. React. Tools like WhatsApp. There's some really great stuff coming out of that place. So the question we all have to figure out is, like, how do you balance that, what they've done for open source and public security, with what they're doing with everything else? And I know
that's Yes, absolutely. And I know they've rebranded, but you've already been referring to them with 4-letter words. So, we'll skip the rebranding part. But to the point about just don't use it, I understand the sentiment. But one of the things I'd also want to caution us about is that who are the user base? How does that, who's being affected? And especially as you point out, WhatsApp has a huge penetration in Asia. So it's not only used for just staying connected to people, but can also be used quite a bit for payments. So you can't just say, okay, stop using this app and you have nothing else to replace it with. That's not to say things shouldn't be fixed. But when we look at this from that, call it the threat modeling perspective or security assessment, what are the alternatives? How do we still serve the user base rather than just come from an area of security purity? And that's, I think, the interesting conversations that can be had around here, that should be had around here. And that's also why I did even pull this week in another article about privacy engineering superheroes. But what this article is really about is the emerging role over the last several years of privacy engineering as a practice. And something that's quite distinct from security engineering or application security, which is what we love to talk about, of course, on ASW. It's in the name. But one of the things that stood out to me of this article is that it goes through some of the privacy engineering specialties. Basically, how do we understand what does privacy engineering even mean in a modern world? It's a type of thing that not many companies are doing right now. But a lot of these specialties like analysis and consulting, infrastructure, tooling and dashboards, user experience, those you could swap those out as security engineering specialties as well. So hopefully there is equal attention being placed on your security teams, and maybe this is also where you can help build where is a boundary to build up or a boundary to tear down between those AppSec and DevOps teams in terms of taking on these roles, especially building on top of that to say, what type of privacy policy do we have? What type of privacy practices do we have within our product so that it is actually serving our users well? And, to basically saying, are we selling a product to the users or offering a product to the users, or are the users the products themselves? Sort of or do we have a future of applications that are privacy friendly, or do we have a future of Soylent Green and the applications are made of people?
And that's one of the interesting things about this is when we talk about privacy, what actually is that, right? It's okay, we don't want to, we want to keep our PII safe for our customers or all these sort of different things. But really when it comes down to it, I think I like this list because it's from that point of view. It's like, these are the sort of the knobs you can play with to ensure privacy, right? These are sort of the parameters you can tweak and adjust based off your budget or based off what data you're protecting or who your customer is. And I like that they called out UX, user experience. That's a huge one to me in modern days. But I think that's this overall list. If you're sitting back thinking about, okay, we need to think about privacy in our product. What does that mean? Okay, well, we can do a privacy policy. That's easy. We'll go and copy that from someone else's website because that's what we do, or some of us. We will, especially if you're a startup. Okay, do we need some sort of tooling internally to actually our dashboards internally to think about what type of privacy information we have from our users, how much of it out there? I really like the comment from Peter in the last half talking about not just logging, but logging the number of records returned. I think throwing that number by itself into a SIM, that sounds like you can do some sort of magical analytics and alerting on that, right? Suddenly, if the number of records you're returning to a customer either spikes or drops to zero, pages should be going off. But I think that's what's interesting about this list. Sit back, think, which one of these things do you feel you're stronger or weaker in, or that you need to spend more time focusing on, or like me, the math and theory, you're just going to push that part completely aside and leave it for Mike.
But you just described a beautiful AI ML if statement there about the number of records coming back. So you've got that startup blood in you, I can tell, John. You've also got a great eye for breaking news and just kind of cool vulnerabilities, cool attacks out there. So there's another article you snuck in here called Trojan Source. I see there's Unicode in there, and handling characters is another dark art in UTF-8, and are they null terminated or whatnot. So no idea where this is taking us, but tell us what kind of ghosts are we going to find inside this article?
Yeah, first let's do our obligatory eye roll, another named vulnerability. So this one popped on my radar this morning. Hat tip to Brian Krebs and his awesome blog. I usually don't see this stuff that quickly, but this came out this morning after, I'm guessing, an embargo. So this is a fun one, Mike. I'll talk through the story and then some interesting things I found when I was researching this morning. So what's going on here is there are nine characters in the Unicode set which allow controlling the direction of text. Is it left to right, right to left? So think about the one that comes to my mind is Chinese. I'm pretty sure is right to left. I'm not sure about the other ones, but I think that one comes to mind. If I'm right, I hope I'm right. But anyway, some languages out there they're read right to left. So when you're typing characters, you want the characters as you type them to go from the right edge of the screen across the left. We do this with comments. Usually you're writing those and you want to read those from left to right, or probably if you're in another language, you want those to go right to left. But what the underlying vulnerability here is, and they've got a really nice animation on the trojansource.codes page. I'll try to remember and paste this into Discord. But really what that means is there are certain situations where you can put a comment either at the beginning or end of a line, and it looks like the comment's there, but actually what it's commenting out can be changed because what's rendering on the screen and what the compiler are actually chewing through can be different things. So in this use case, they've got a comment at the beginning of the line saying, hey, this line is for checking for admins, and then there's an if is admin after it. But then when they render it correctly, you realize that the if is admin is inside brackets or inside the comment, and you're actually running that code, which was only supposed to be run by admins. Simplistic, but that gets the idea across what's going on here. There's a white paper. Haven't had a chance to read it. I'm sure it goes in more detail what I just said. But what's the interesting thing about this? This is coming from University of Cambridge. What's interesting around this is, to our knowledge right now, this is the first vulnerability which is cross-programming language. So any language that has some sort of commenting capability in there and is able to, parse and use or accepts Unicode characters, which are most nowadays, at least in the comments, you have the ability to do some hanky-panky stuff going on in here. I've got my word in from my bingo card. But so let's take a step back then, and what they did with this is they did a organized disclosure across a bunch of different languages. I saw this morning on OSS Security the announcement for Rust C, so I started looking at that one and how they were fixing it. And then they also have mitigation in there. Is how I know they actually recommend mitigating out 9 different, or looking for these 9 different Unicodes in your source. And if you see those, there's a chance that something is going on in there. So so this could be fairly large from that. But what's interesting, as I was sort of teasing there, as I was looking around and I wanted to go, hey, does Go have this yet? And there's no releases out this morning. I haven't checked in the last hour or two to see if they've got anything in the news about it or in anything they're publicly saying. But let's see, where did I put this? It is this one. Golang's ticket 20,209 issue from 2017 proposal: disallow left to right, right to left characters in string literals. So someone had been thinking about this earlier, which, if that's the case, makes me wonder if someone else has seen this and maybe gone a little bit further with this before the guys over at Cambridge. So prior art has been around for a while on this one. Maybe not in a comment, but at least in source code, people have been thinking about it. So that I think we might see some interesting news in the next week or two as a result of that.
Very, very cool. And I think the only thing I can add here is that hopefully this is something that can be addressed at the language or compiler level, let alone the IDEs, to be able to be more explicit about these changes in the bidirectional nature within a single line of text, so that this doesn't become, so it's basically, it's more scalable if you can get down to those particular parts of the tool chain, basically the building part, and hopefully this means it's a cool attack, but won't become so pervasive that's what's going to be on the OWASP 2024 top 10. And the only other thing I can add here is that it's taking an advantage of the bidirectional, so I would have called this bad directional as my named vulnerability. So we can grow in there, and you can send feedback about how poor my naming skills are off the cuff. But before you do that, do take a note. One last article I was just highlighting, the all-day DevOps, and haven't a ton of presentations. Haven't had really a chance to go through there. I have a couple of them that were DevOps culture security related that I had marked to go watch after the fact. But listeners, if you have some favorite presentations from the All Day DevOps that was just last week, let us know, share, especially if there's something that you learned that was interesting, or there was a particular presentation that you'd want to highlight and amplify for our listeners to also take a look at. And with that, I think I'm out of news for the week. John, how do we feel here?
I'm the same way. I'm looking forward to our listeners crowdsourcing what we should be paying attention to there, and hopefully we'll talk about it next week.
Absolutely. And want to thank you, John, for joining me. Want to thank everybody for hanging out in Discord, and all of our listeners, because as John said, we hope you, you don't have to do all the work for us, but you do have to please come and listen, because we'll see you next week on Application Security Weekly.